Our first step in cookie production is when the mixed dough is loaded from a mobile tub into a live bottom bin. Once in the bin, a guillotine cuts chunks of dough, and a conveyor belt on the base of the bin moves them to an incline belt called the feed conveyor, or the chunker belt, that will move the dough to the rotary molder. The chunker belt is normally a 2-ply polyurethane belt, or a 2-ply oil and fat-resistant PVC with an inverted pyramid top profile or similar to provide grip on the incline conveying. The belt is usually blue or white in color, and like all belts on this application, it must be approved for direct contact with food. As the dough enters the hopper on the rotary molder, it passes through a system of rollers to produce the final cookie shapes. A forcing roller draws the dough into a pressurized cavity between the forcing roller and the molding roller, where the final shape of the cookie gets cut. A scraper recycles the extra dough, while a pressure roller on the bottom pushes the belt against the molder roller to help with the extraction of the final cut shapes. The belt used on the rotary molder is usually a 1-ply solid woven cotton belt. The belt can be 100% cotton or be mixed with polyester or nylon to increase the belt life. The fabric of the belt can also have different weave types, like plain or twill weave. Both the weave type and the fiber used will play a role on the extraction capacity of the belt, as well as the release properties of the final cookie onto the next belt. The raw cookies now enter the oven to be baked. Cookie baking ovens, also known as tunnel ovens, have long conveyors that carry the dough pieces through a heated baking chamber. Oven lengths vary typically between 25 and 100 meters long. The conveyor can move at different speeds, allowing the operator to adjust the baking time. Ovens are designed to transfer heat either by radiation, convection, or conduction. The conveyor band material is a wire mesh or a carbon steel band, which turns around large cylindrical drums at each end of the oven, and it needs to withstand high temperatures for long periods of time. After baking, the cookies need to be cooled to room temperature. This is done by a series of conveyors carrying the cookies for close to double the time of baking. The cooling also helps reduce the moisture from the center of the cookies, which is much higher than the outside. If this moisture is too high, the cookies might break after packaging. One-ply and 2-ply polyurethane belts are used here. If the temperature of the crackers is still high, a polyether-based polyurethane or any other high-temperature polyurethane is recommended. If the cooling has any inclines, then a glossy finish is recommended, since it provides the belt with better adhesion or grip. To reduce the overall length of the system, some companies have curved belts. The curved belts need to have the same properties, with the added property of having flexible fabrics that will provide traction on a curved conveyor. After cooling, the cookies enter a turning or flipping machine. In this machine, every other row of cookies gets turned upside down. Once the cookies are flipped, they go through the cream filling machine. The cream filling machine deposits the cream in the center of every other row of cookies, the row that is upside down. A robotic arm then picks up the row of cookies without filling and deposits it on top of the cookies with the filling to create a sandwich. Any 1 or 2-ply polyurethane belt suitable for small nose bars can be used in this section. In case there is any spilling from the filling machine, it is preferable to use a non-stick matte surface belt for the whole section, so the cookies don't stick to the belt. After the sandwiches are formed, the cookies are ready for packaging. The first step on the packaging is to stack the cookies. The two main stacking systems are in pile or on edge. The The one showed on this video is the on-edge flow pack system, where cookies get stacked on their edge. Sometimes the cookies can be loaded into tins by hand, or into plastic bags via vertical form-fill seal machines. Once stacked, the cookies can be loaded into trays, or can be wrapped in plastic using flow wrapping systems like the one showed in this video. The final stacks of wrapped cookies can be put into cartons, boxes, or tins via automated systems or manually by operators.